Hey, what's going on, guys? Welcome back to another Codeland Retreat video. Today we are not going to be going into any new mathematical concept to add to this library. I've added a few features to the sets area, which is what I'm going to be showing today. Uh, but before we get into the video, can you just scroll down through the video just a little bit and click that like button? It really helps me out. Also subscribe if you want to see more content. But anyway, let's get into the video. So as always, I'll start by demonstrating by demonstrating the library working. So we have the normal line to import Mathlib. For Mathlib, okay. Now I'm going to create a set, and usually you would just pass in values like this, right? Yeah, you would pass in values like this, and this still totally works as well. But there are some times that you want to use, sometimes you don't know the data sets but you know a particular rule, or if you don't want to continuously sit and type out set values. In that case you use something called a rule. Okay, so what a rule is? A rule is basically something which shows all the elements in a set. It's like a for loop in Python. Uh, it goes like from I in range 1 and 100, stuff like that. How a loop over here functions is an x such as this symbol spike over here. It means such as x is equal to n, and n is a number, okay, and n is in a range. So if you want the first value, you find 0 is lesser than n, so the first value of n will be 1, and since x is equal to n, the first element of the set is 1. Then we move on to the second one, it's 2, till it gets stopped by this lesser than 7 remark over here. Now if you want to make a set like this, I have coded it for that. Now there are some special properties for sets which follow a rule. When you sort these sets in the ascending order, this element minus the element before it is a particular common difference which is the same for all of the elements in the set. So 6 minus 5 is 1, and 5 minus 4 is 1 as well. 4 minus 3 is 1, and so is 3 minus 2. 2 minus 1 is well. So in these sets, the nth term minus the n minus 1 is equal to the n minus 1th term minus the n minus 2th term, second term. Also, uh, I've added a new feature called difference of two sets. Now what a difference of two sets is, if this is set A and if this is set B, the difference of these of A minus B is equal to set A minus the intersection of these two sets, which is in the middle. And as you can see, according to the legend, this is A minus D, A minus B. Now for B minus A, it's the same, but it's this other side. Now A delta B, over here this delta is the Greek letter, but it is called in mathematics as symmetric difference. So a symmetric difference is basically A minus B union B minus A. So it comes this part union this part. So if this entire thing were to be a universal set, then this small thing would be a intersection, then the intersections complement of the entire in regarding to this set would be a symmetric difference. So that's the coding that I have done for this video. Now let me get into showing it. Okay, so let's create a set using a rule. Now suppose I want multiples of 5. I want, let's say, 10 multiples of 5. So create set from rule. I've made a function. Now you have to pass in a string with a particular syntax. So x such as x. Now this is equal to a constant multiplied by n. N is the one which defines the entire range. Now since I want multiples of 5, I'll do 5n. Then I add a semicolon. Then what I need to do is, I need to define a range. Now let's say we want the first multiple of 5 starting from 5 itself. So I can say 0 is lesser than n, in which case the first value of n will have to be 1 because it is lesser than, not lesser than, equal to. Then we want it to have 10 multiples, so 11 will come over here. Now if I do print elements of, first 10 multiples of 5 are, if you don't know, this is what is called an F string. It is very helpful in Python. Okay, yeah, so it came 5, 10, 15, 20, 25, 30, 35, 40, 50. So we've got the first 10 multiples of 5. Now let's say I have not created this. I don't know a rule. If I have, let's say, a jumbled up sets of, let's say, the multiples of 2. Okay, I have this, suppose. Anyways, yeah, so we're back. So there was a very weird glitch which just happened. But anyway, so find rule from set. And I'll insert set. Then I'll print x such as x is 2n because it's multiples of 2. 0 is lesser than n because it started as 1. Lesser than 6 because it had only 5 multiples. So yes, the code works. Now we move on to the final features, that is difference of sets. So let me quickly do this. Set 1 equal to set 2, and I will just put a few numbers. Set 2, set. Now, difference of these two sets, first difference will be like this. The second one will be reversed, and it will be symmetric difference of set 1 and set 2. That is how it will be. Now if we print Okay, so it works. Difference 1 is 5 and 87, which is basically this set minus the terms that are common, which is 6, 7 and 2. Now for this it is the same, and the symmetric difference is basically the union of these two sets as seen here. Okay, so those were all the features for this video. Now let's move on to how I coded this. Now for the create set from rule, we input a string called rule string. Now in the rule string, if we look over here, in a rule string, the string is arranged in x such as x is equal to, and over here we multiply some constant with n, then we put a semicolon, then we say a lesser value of n is lesser than n is lesser than greater n. So this is how you create a rule string for my particular program. So what we do is we create a rule by just splitting it at the pipe over here and saying this is the rule, because this actually is just showing that x such as x, which just shows which is just mathematical representation of how you're supposed to define a term. Then what I've done is I've split this rule at the semicolon into two parts. Part 1 is x is equals to constant multiplied by n, and part 2 is the thing defining the bounds of n. Now the constant that n is multiplied with here is part 1. Okay, one second. Here you split part 1 at the equal to mark, and the thing that comes after that is part 1 n. Okay. Now constant n is that split at n, and we take the thing before it. So we're just pruning down the entire string to just get this much. I could have used slices, but it is confusing, so I'm not going to be using slices. Also, it is not dynamic because over here it even works if you were to enter a 5-digit number, in which case the values you would get will skyrocket. Anyway, constant n, now that is found, this over here is found, we need to find the lesser and greater out of the string, in which we just parse this second part by splitting it at the lesser than marks and then finding out which is lesser and which is the greater one. Okay, now I created a list called elements. For every number in range, for every number in range, part 2 lesser and plus 1. I mean, in testing over here, we have used 0 lesser than n lesser than 11 in order to get multiples of 5 from 1 to 10. So we add 1 to the lesser and subtract 1 from the greater. But since Python starts counting at 0, we don't need to subtract it from the greater one. Now what we do is we multiply x, which is the number, which is the value of n, with the constant n, and then we get one element. We append it to the elements list. After this, we return a set of elements. Now for find rule from set is basically the thing reversed. We find the set elements, we sort them because that's how you find the rules. We create a list of D's. D over here is common difference. Now for every element in set elements, we check, we find out the index of that element. If the index is 0, we do nothing. Otherwise, we subtract that element from the element that came before it. Then we take that difference and we add it to the difference list. Once this is done, we'll have differences. Now, this is basically checking whether all the differences in this D list are the same. If they are not, it will return not possible for the given set and it will break the thing. Otherwise, it won't do anything. Now constant n is actually what d is over here. So d is found. After that, n lesser is basically uh, the first element divided by the constant minus 1. So if the first element is 5, let's say, and the constant n is 5, first n lesser will be 0. And n greater is the last element divided by the constant plus 1, like how we had discussed. Then I just use an f string in order to place these variables in the regions they need to be. And just like that, we return rule string. Now a difference is basically I take set1 elements as I take set1 and set2 as lists. Then what I do is I find the intersection of these two sets and I call that the intersection elements, and I take the result as a list. Then what I do is for each element in set1 elements, if that element is not in the intersection, because over here if we see in this particular diagram, we are removing from this set the elements which are there in the intersection, which is why it is important we remove that. So if it is not in the elements, then we append it to the result list and we return it. Now symmetric difference is union of the set of differences of these and set of differences, because differences returns an array and not a set. I emphasized this on the first video as well. By the way guys, that was it for today's video. If you want to see more, do be sure to subscribe and click the notification button so you will never miss my uploads. This is the third part of the series. Now most of the time I'm going to be adding more features, and sometimes like this video I'm going to be refining on them. And I leave a paste bin for this code down below because it's still just one file. I'll leave a paste bin link in the description, and along with that I'll see you guys later. Bye.